concept of assets. You have a house, you cannot drop or copy house. Same thing applies to money. Ownership is the key value of Move. Versioning is a trust problem. Trust in code is a very difficult thing. I'm Dario. I'm currently the manager of the Move team, the Move effort at Miston. I was there when Move was first defined in Libra. I used to work for Facebook. I actually worked there for a couple of years, two and a half years. Then it was clear that Libra was never going to shape a Facebook, so I actually decided to go and do something else at Facebook. And then all the people that stayed around, eventually they moved and they create the two most well-known company. I don't know if they were well-known, maybe I don't stretch, the Aptos and Miston. And then I came back, worked with both groups a little bit. And now I'm back to the blockchain Move story, which is kind of fun. And this presentation for me is a little bit to give you a sense of where, sort of it's a little bit my journey as well, as much as is the belief that the Move team had originally, and sort of the evolution of Move and what's coming in a sense of what we think is important things that, or properties that Move as a system should have. So you probably have heard that. I mean, this is originally on the right. You see the famous one-pager that Sam used to go around trying to shop for people and try to collect people to make the, to create, to build this language, right? And, I wanted to go through the principle of them because I think they are somewhat important and they are where we all come from, right? I mean, so if you're working on Move, effectively, those principles are there for all of us. Is what characterizes Move, what makes Move what it is, right? So first off, at the time, we have a concept of resource. Resources today are expressed different. As you know, there are abilities, and we'll talk about that. But the concept of resource was pretty much that, if you have a resource, a copy operation or a drop operation on resource fails. And that matched very well, as you can only imagine, the concept of assets, right? I mean, you have a house, you cannot drop the house or copy house. Same thing applies to money. And so having the system that actually gives you the guarantees, having the language that gives you the guarantees was, felt incredibly useful and very intuitive in the way you program. Then there was the issue with reentrancy. Reentrancy at the time, and even now, was one of the main way to cause problem in blockchain, but, quite frankly, generally in programming, right? I mean, we all know that reentrancy is a very difficult thing to deal with, right? And so, and the idea is that, well, let's make sure that, some reentrancy patterns are effectively impossible in the language. If the property of resources before is a property that I believe we all came to love, the dependency is a little bit less loved because, of course, you cannot do cyclic dependencies in any form or fashion, and that sometimes requires you to write code in ways that it's a little bit less, I wouldn't say intuitive, but maybe a little bit more involving, for lack of a better word. However, that was a very critical property, and a property that is still true, and a property that is still, we feel it's extremely important to avoid kind of problem or bugs. And then there was the concept of ownership. This was, somewhat coming from Rust and the borrow checker and the way references are used in Rust. But what I want all of us to really focus on here is that the principle of reference check in Move was not really related to memory, dangling references, or node pointer exception and things like that, even though it does have that side effect. But it was more related to ownership, right? The principle is, if I have a reference defines some form of usage, I have that object somewhere on the stack, on the call stack. I have ownership over something that then I'm using as a reference. And I think, you see pretty simple example here, right? I mean, I have a, extract, I have a function, and if you look at the bottom, where we have let value and percent value equal value the end resource. So it's clear that the reference that is coming back, it's rooted into something that's on the stack. Again, that concept is pretty critical for that. So as we were starting with the one pager again, we got a group of people together. We're like, okay, we have a one page. Now we have to write the rest of the 300 pages of this spec. Let's move forward and let's do that. One thing that came, one of the first things that we did, we started actually. This is more of as a I don't know, as a curiosity more than anything else. We started with a more object-oriented approach. At the beginning, there were, like struct and, impl, Rust, or, more classic object-oriented approach. But then we found that was incredibly, it exposes references too much. It was very difficult to write code that felt safe. And so we moved to the concept of module. So module is one of the things that came, one of the first things that came in Move, and it proved to be a pretty good approach where it felt like much more in line with the concept of a smart contract, much more in line with the concept of exposing an API that is, it's not tied to a single object, right? I mean, that it's tied to a namespace, so to speak. So that was sort of the first thing. I mean, module proved to be a good thing. Next thing after module was generics. Generics, the introduction of generics was, of course, extremely powerful. It's the one way you can program in Move in a very abstract way. Generics were a lot of pain. I mean, was ridiculous the amount of problems that we had with generics. And as I said at the end, I mean, as much pain as it was also the impact that generics had was as big. But if you read the last line, I mean, generics had a lot of moments where you say, where you have problems and you're like, wow, I didn't see that coming. I don't know, if you're programming, you're probably used to that kind of situation where, sometimes you're like, what? And it's really, really strange. So it was really funny. But generics were, incredibly useful. And then, there was the abstraction from resource to abilities. And I think abilities to me was the moment where Move as it is today is defined. I mean, introduction of abilities is really what makes Move an interesting language. What are abilities? Abilities, as describe that on the left very quickly with, so when you define a struct, you have the ability, in fact, you must, to say whether the struct has copy, drop, store, or key. So copy and drop are the way effectively you define a resource, right? I mean, so if a struct does not have copy or drop, you're back into the resource world. Means that, the copy operation will fail on the value and the drop operation will fail on the value. So thanks a lot. This is out. No, that's good enough. Don't worry. And so there is a lot of, there's a lot of values and a lot of ways, particularly with generics, that you can use abilities that will give you an interesting way to do programmability. And one of the things that sort of abstracted the concept of abilities was the idea of the hot potato. The idea of the hot potato is described here, if you see that, right? And it's basically the idea that if I have ticket that is no copy, no drop, no key, no store, so no ability whatsoever, the implication is that ticket can only be used on this stack, right? And that has an interesting property, because if you think about that, I can force people into an API, right? I mean, so here, I have an asset in, I call an API that returns me a ticket, conceptually, or whatever that is. I must use the ticket all the way to the end. So it's basically, you have a way to force people into a specific API with the idea of, abilities and hot potatoes, and to do all other very interesting things. So this stuff was, the abilities, I feel like, it's when Move came to life. There were difficulty with moves that we always had. One of them was the problem with storage and the storage inconsistency, and particularly the storage by code. So sorry if I'm going a little bit into much details here, but yeah, I think it's kind of interesting to talk about that because that's something that always bothered us, and particularly me. I mean, I was one of the guys that felt particularly odd. I guess I'm the one to blame for the bytecode in a sense. So maybe that's why it bothered me a lot. He always had problem, and let me explain the problem because I think they're important. To describe. We originally with bytecode operation, I can do a borrow global and a move from, right? I mean, so I can get a reference and then I can move the object that the reference was from. I can move it out. So this is creating a sort of aliasing that it's impossible to express in the language. So if you have pure move, this code is impossible to express. The compiler will choke on you. So if you add this code, it would be like to say, let resource ref n% resource equal, let's say n% r, and then you say move r to another location. The move compiler will choke on you, even if you were able to write that code by hand. The verifier will never let you publish that. So this was a strange thing. Now all of a sudden you could do something that you could not do in move with bytecodes. And so how did you protect around that? First we started with runtime protection around global data. We really didn't like it because, move was completely static except for this part. So it was difficult. And mutability as well. We had promise of mutability that are not honored by the bytecode over storage. And that's when we introduced the acquired. So if you ever worked with a move that is still as, or the legacy move, let's call it that way, and the acquire, you'll find out that the acquire is a solution to this problem, but they also create a different kind of problem in creating a constraint where now this code is not possible anymore. And this code is perfectly legal in move if you had move. So storage was really strange. You had a little bit of stack magic. If you say borrow global, right? And we talked about that thing that ownership, right, is the key value of move. And if you're doing a borrow global with the bytecode, well, where is that data? Where is it sitting? Where does it exist? And it was very difficult, this idea that you have a pointer to something that is not on the stack, that something exists somewhere, but no one really knows where it is. And of course, you know where it is because, you can make that work. But it was, again, was strange. And the other thing was, permission as well. I felt like, having the bytecode forced the move to have a responsibility that it didn't necessarily have to have. So we tried to remove the storage bytecode, and actually things looked pretty nice for us. That actually was a switch in the programming model, obviously. Not everybody is particularly keen or happy about that. But it was very good for us. What are the implications of that? The implication of that is that all the objects that you are operating on are passed in. Essentially, let's go back to that concept of ownership, right? I must own something that I'm using. That is the principle that we stayed behind, right? And said, well, at that point, like whatever you're using, you're passing that in, right? And as you're passing that in, the problem of permission is lifted to a different layer, right? It's not necessarily all inside move, but happens to be also outside. Not only that, but if I don't have ownership and I cannot do things, right? I mean, I cannot even enter the execution layer, right? With the bytecode, with the search bytecode, you enter the execution layer and you fail, which is fine, I suppose, but you still enter the execution layer. This way, the idea was that you don't even enter the execution layer. But now, how you define those objects that you have ownership on? So we started with two very simple models. The idea is that you have a known object, and a known object basically is something that at the entry layer you provide ownership and permission about that, typically done through the classic blockchain mechanism, and now you have that. So that's actually a pretty good model. And shared objects were objects that are effectively owned by anybody. Right, I mean, you can think about a DeFi pool, right, as a pretty clear example. You want everybody to be able to operate on that, and so everybody has that. So those two actually allowed us to move forward quite a bit, but there was something missing still. The first thing that was missing is the concept of lazy, um, storage or initialization of object, I mean, the ability to break up the object such that you don't have a single massive object. Right? I mean, that's a pretty critical step for everybody, right? There are implications of having an object that grows too big, from growing too big, period, to being very expensive and things like that. So dynamic fields basically for us are a way to reintroduce the concept of loading things lazily. However, the thing that is critical about dynamic field is the dynamic field in terms of ownership, they belong to the object that was passed in. The ownership is to the object. So it didn't change anything in terms of ownership. So it fitted very well with the idea of ownership, where I have to pass the object, and the only way to access the dynamic field is if I have passed that object that I have ownership on. Next few slides are going to be pretty dense in a way that, I guess I don't know how to do slides in the next 5 or 10 years. I'm pretty sure those slides will be perfect. But for now, I mean, you can go back and read them, and I'm going to try to express what I'm trying to say conceptually, right? So we have this idea, as I said, we have own object, single person. We have shared object, everybody. There is something missing. There is something missing in a variety of different ways, and it's something that we're addressing actually. And we're having, we're talking about this stuff these days. And it's actually a pretty interesting feature that we're providing. But the idea is that you want multi-party object. The idea behind multi-party object is like take any group of people inside the room, and you may want to say, we want an object where each one of us, so very different than multi-sig, where each one of us can have the permission to use that object without necessarily interacting with anybody else, right? I mean, I have permission because I have ownership over that object. So all of those things are coming, and we believe that they're going to make the programming around that ownership much, much more powerful. So we're really, really looking forward to that. That's going to be an interesting evolution. The other aspect, we talked about object. We talked about some of the principle about ownership. The other big deal that was never a part of the one pager, there was never much, is the whole idea about deployment unit, right? We started with module, as I said. We moved, we started with classes or struct, or object oriented. We moved away into a module world. We now know that packages as a unit of development are much more critical. I mean, module per se are a little bit too strict in what they allow and what you can do with them, right? So we introduced a concept of packages, which I think it's pretty much every move system is actually introducing because they're pretty vital. And and when you have internal visibility and the ability to program within a package in a private way, if you remember, right, I mean, you have module, you have a public API, and you have a private API around modules, right? And the idea was like, the module encapsulate quite a lot. Here we want packages to be more what, in a sense, module used to be. But then packages are also more, and one part that it's not clear to us, and I think every move system should really think hard about, is should packages define, if you wish, an interface, right? I mean, like what I'm calling here protocols, package families, for lack of better words, right? But I mean, some way to describe this is what a package is, irrespective of the implementation. That is not there yet. And the other thing with packages is, and then we have a move registry and package management, what we're calling mover, that is pretty critical. It's just the entire ecosystem, right? Where do I find packages? How do I discover packages? What kind of information I have about packages? That is not really a technical problem, right? I mean, that's more of a, ecosystem problem, but it's pretty vital. We think that, Ethereum has got a pretty good story with that. I think we need to grow into that much more. I mean, that's very important for people, for builders, for people that are looking for good packages. So that's another part. Packages also introduce the famous package version problem. And versioning is, I mean, I don't know, for me personally, the most painful thing that is still there in Move. And this is also something that, like Move community at large, and then Move, irrespective of what specific movies out there, whatever the dialect or specific implementation of movies, versioning is hard, right? I think versioning, as we all know, has got the great tension between the two extremes, right? I mean, which is rug pulling, please do not ever, change the package that I'm using. And bug fixing, which is like, please change immediately, right, the package that I'm using because it's bogus. And of course, those two actually are contradictory in terms, right? So how do you do that? There's been a lot of talk about versioning. People talk a lot about that. I think sometimes, the talk around versioning are much more related to the technicality of versioning than I think are the mechanics, which I think are very immaterial. I mean, to me, versioning is a trust problem, right? And how do you describe that trust in code is a very difficult thing that we do not have an answer for yet. I don't know that anybody has got. Let me talk about some of the principles. If I have an own object, again, I own the object, right? I mean, it's mine. I'm the only one that can present that object in input, and I'm calling some code. I think we can agree that, you do not want ever anybody to be able to change that code underneath you. I mean, that should be impossible, right? I mean, that's a principle that sounds very, very sound, right? And we honor that. We do that. We think that's extremely important. However, for multi-party objects, for objects that are more than one people, particularly shared object, what is the versioning story? How do I know by using an object what are the possible evolution of that package? I don't know. I think it's a difficult story. Again, I think that's something where us as a community need to think really hard about it and talk about that. Of course, there has been a lot of evolution in the Move language. This is literally language stuff. I think, pretty much every Move system that you take, no matter where it's coming from, evolved the language quite a bit. I think, macros, enums, receiver syntax, all those things are coming. And you can expect more coming because the language has to modernize, the language has to move forward. There is no doubt about that. And I think you'll see quite a bit there. We have done a lot as SWE in this space. But, again, I feel that's a space that everybody is trying to move forward, that we're trying to find a unified view. However, having said so, I think it's difficult to, the idea of a single move to me kind of dies a little bit the moment you are talking about different storage model. It gets very, very difficult to come up with something that is universally, where you grab the code, you move the code to the other side, and boom, works. And I don't know if there is an answer to that because, if you think about that, it's literally what, blockchain are fun enough. Data store exposed in one form, right? So if that data semantics is different, it gets a little bit tricky to work around the edges. But the language is evolving in a way that feels relatively consistent to me in a lot of those things. So to summarize, object ownership, we talked about that. Object ownership is one aspect, right? Defines how you pass object in, who's able to do operation on the object. But then your transaction programmability is really the big deal. Transaction programmability is really something that, we're doing through PTB is that you want to give users the ability to compose code in ways that are simple from user to do, and they are extremely powerful. We're thinking about signatures, and I think, once again, every Move system that is growing is thinking about that. If you think about that module interface, module trace, call in whatever you want, but signatures are particularly important when you look at them as PTBs, right? So your ability to, again, compose code, I think there is quite a bit there that we're doing, and there is quite a bit that is coming. And I think it's probably where, again, a lot of the Move ecosystem, all of us will have to think hard because that is where the power comes from. And then as a last thing, and this is the last thing, I have the gas metering revisited. And the only reason why I mentioned that is because, gas, as you all know, is a funny thing, right? Can screw you up completely. People sometimes go change a single extraction. There has to be a way to make gas less in your face and make gas also something that can promote good programming. We're looking into that. It's not an easy thing. I'm super curious if anybody has got idea, but gas golfing, as you know, it's I don't know, annoying as hell, I would say. And that's pretty much it. That's pretty much where we're going. So that's all.